So picture the HDMI cable stuffed behind your TV right now. It's, thick, it's rigid, and probably maybe 3 feet long?
Yeah, usually around 3 feet, right?
Right. So now imagine stretching that exact same cable across an entire football field. I mean, most of us think a cable is just a cable, but at that massive scale, copper stops working
It
entirely.
completely fails, yeah.
And you actually have to start bending light.
Mm.
So, welcome to the deep dive, where today we are exploring the massive hidden world of commercial audio and video distribution.
It really shatters our everyday understanding of how AV setups even work.
Hmm.
Like today we are using a product page for this DVIGear DVI-2580 AOC HDMI cable as our starting point, and that AOC part stands for Active Optical Cable.
Right, because this specific cable is 80 meters long. That is over 260 feet.
Exactly.
And like we said, at that distance, a standard copper cable just gives up, right? The signal just degrades into static.
Oh, absolutely. I mean, copper wires have electrical resistance.
Mm.
So the longer the wire, the more that high bandwidth electrical signal slows down and basically scrambles. But active optical technology solves this completely by converting the electrical HDMI signal into light.
Which is just wild to think about.
It is. And light bouncing through a glass tube has virtually zero resistance. It completely ignores electrical interference, so it arrives perfectly intact 260 feet later, where it gets translated right back into an electrical signal.
Okay, the physics of turning video into light is incredible, but I have to ask, who on earth actually needs a TV signal to travel the length of a football field?
Yeah.
I mean, unless you live in a literal castle, this seems like total overkill.
Well, you have to think about environments where failure just isn't an option. We're talking colossal sports bars, sure, but also really heavy-duty government environment.
Wait, the government? So, like, the military's buying industrial HDMI cables.
Oh, massive quantities of them. They purchase these through specialized federal contracts, like the GSA schedule or NASA's WP programs.
Oh, okay, well,
And those programs handle extremely high-end tech procurement for the government because they need flawless transmission across these massive, complex facilities.
right, but if I'm running a facility with dozens or even hundreds of screens, I can't just plug one giant glass cable into a wall and call it a day. There has to be a centralized brain, right? Like a digital traffic cop that decides which video signal goes to which specific TV in a split second.
Spot on. And in this ecosystem, that traffic cop is called a matrix switcher. Specifically, the catalog we're looking at highlights these Wolfpack switchers. And the scale of these devices is just staggering.
How staggering are we talking?
Well, we're talking about routing flawless high-definition signals to 80 or even 160 different displays simultaneously.
Managing 160 displays sounds like a full-time job for an electrical engineer. I mean, if I'm the guy running a sports bar, I am definitely not standing in front of a giant wall of 160 remote controls. There has to be a simpler interface for the humans actually pushing the buttons.
Yeah, and there is. They solve the human element using specialized tablet controls like the WolfPad.
Oh, the wolf pad. Got it.
Right, along with web-based dashboards and dedicated mobile apps. It basically takes this wildly complex matrix of 160 intersecting signals and turns it into a simple touchscreen map.
That makes sense. And controlling those screens isn't just about, mirroring one image 160 times. You want to slice and dice the visual experience. If I
Yeah.
have a massive wall of screens, I want to manipulate them.
Exactly. It's about complete visual manipulation. So the hardware includes these extensive video wall processors. You could start small with a 1x2 screen configuration, or you could scale all the way up to massive 10x1 video walls.
With picture-in-picture capabilities, too, I saw. You could have one giant room-sized display showing 4 different live data streams or sports games, perfectly synced.
Yeah, and the sheer amount of data required to do that is only growing. The industry is already rapidly shifting to next-generation 8K HDMI products.
Which is a massive jump in data. Huge. Pushing 8K resolution requires an exponentially larger pipeline of data, which makes that active optical light conversion we talked about not just a neat trick, but absolutely vital. Copper just cannot handle that future.
Wow. So the next time you are sitting in a massive sports bar, watching 50 different games in perfect sync without a single stutter, think about the miles of hidden optical glass and the massive Wolfpack matrix switchers working silently inside the walls around you.
It really is an entire invisible infrastructure.
It is, and it makes you wonder, as 8K and eventually 16K video become the new standard, will our own living rooms eventually require these industrial glass nervous systems just to watch a movie?